In this class I am going to explain you about Raoult's law. What is the significance of Raoult's law? Raoult's law is used to determine relative lowering of vapor pressure of a solution containing non-volatile solute. Raoult's law is also useful to determine the molecular weight of non-volatile solute which is added to the solution. So that is the main significance of Raoult's law. Before going to understand about Raoult's law, we need to understand some concepts which are involved in Raoult's law. So those concepts will be discussed one after another. See, first one, vaporization. Vaporization means the transformation of a liquid into vapor. Liquid changes into vapor. It will be possible by gaining of heat. Because heat is absorbed in this process, it is an endothermic process. It is an endothermic process. And here liquid is transformed into gas. So this is vaporization. What is the reverse process of vaporization? Condensation. Condensation. Condensation is the process in which gas is transformed into liquid. So during this process, heat is liberated, released, so that it is an exothermic process. Here vaporization means liquid is converted into gas. See, for example, we are taking some liquid in a beaker, we are heating, temperature increases, we just heating. Here temperature increases. When temperature increases, kinetic energy of solvent molecules increases. Those solvent molecules are coming out from the liquid, from inside of the liquid to outside of the liquid through surface of the liquid. This is called vaporization. When we raise the temperature, what happened? Kinetic energy of solvent molecules increases. Those solvent molecules moves upward from inside of the liquid to outside of the liquid through surface of the liquid is called vaporization. So after getting vapor, because it is a closed system, there is no scope of escaping of vapor from that beaker. When vapor is formed here, this vapor, when it is equilibrium with liquid, this vapor when equilibrium with liquid, it exerts some pressure on the surface of the liquid. The pressure exerted by vapor over the surface of the liquid at a given temperature is called vapor pressure of the liquid. It is what? Vapor pressure. Vapor pressure means pressure exerted by the vapor over the surface of the liquid at a given temperature. That is what? Vapor pressure of the liquid. Usually we are denoting like P0. P0 is what? Vapor pressure of pure liquid. So now, what we are doing here is, see, it is the liquid. Generally liquids are of two types, volatile liquids and non-volatile liquids. Volatile liquids mean the liquids which are having low boiling point and high vapor pressure. Low boiling point and high vapor pressure, like acetone, diethyl ether. Okay, these are volatile liquids. These are having low boiling point and high vapor pressure. Non-volatile liquids mean liquids having high boiling point and low vapor pressure. Those liquids are said to be non-volatile liquids. Example, water, benzaldehyde, aniline, like that. These are non-volatile liquids. So this is the classification of liquid based on volatility. Now here we are taking a pure liquid. Say for example, if it is water, we are going to form a aqueous solution. So it is a pure liquid. It shows vapor pressure, that is P0. We are adding some solute which is a non-volatile solute. What kind of solute it is? Non-volatile solute. Solutes are of two types, volatile solute and non-volatile solute. Volatile solutes are the solutes which evaporates at room temperature. Non-volatile solutes are the solutes which does not evaporate at room temperature. So we are adding non-volatile solute to this liquid. What happens? Solute dissolves and form a solution. When we heat that solution, vaporization starts, vapor is formed, but when compared to the pure liquid, less amount of vapor is formed because these solute particles prevents the flow of solvent molecules to the outside of the liquid. That's why less amount of vapor is formed. That vapor exerts some pressure over the surface of the solution. This vapor pressure is said to be vapor pressure of solution. Vapor pressure of solution is relatively lower than that of vapor pressure of pure solvent. So P naught is always greater than P. So P naught minus P is called lowering of vapor pressure. Lowering of vapor pressure is the difference of vapor pressure from vapor pressure of pure solvent to vapor pressure of the solution. Okay. So what about relative lowering of vapor pressure, RLVP? You know RLVP is the colligative property. What is the meaning of colligative property? Colligative property means the property which depends only on the number of solute particles but not on the amount nature of solute particle. That is colligative property. We have four colligative properties. One is relative lowering of vapor pressure, second elevation of boiling point, third depression in freezing point, and the fourth one is osmotic pressure. See, relative lowering of vapor pressure. It is the ratio of lowering of vapor pressure to vapor pressure of pure solvent. It is relative lowering of vapor pressure. So this information is needed to understand Raoult's law. Now coming to Raoult's law. What is Raoult's law? So we have two statements under Raoult's law. The first one is vapor pressure of solution containing non-volatile solute is directly proportional to mole fraction of solvent. Mole fraction of solvent. See, in a solution, it is what? Solute. It is solvent. I give the number 1 for solvent, number 2 for solute. Small letters are for solute, means weight of solute is small w, molecular weight of solute is small mw, weight of solute is capital W, weight of molecular weight of solute is capital MW, and mole fraction of solute is x2, mole fraction of solvent is x1. So what is the first statement of Raoult's law? First statement of Raoult's law is vapor pressure of solution having non-volatile solute is directly proportional to mole fraction of solvent. So it is P is directly proportional to x1. So when we remove this one, P is equals to P naught into x1. Okay. So it is what? Raoult's law. So the second one, the second statement of Raoult's law is, relative lowering of vapor pressure of solution having non-volatile solute is equals to mole fraction of solute. Again I am saying relative lowering of vapor pressure of solution having non-volatile solute is equals to mole fraction of solute. RLVP of solution is, can be written like this, P naught minus P by P naught. So I substitute here, then Raoult's law equation comes, it equals to x2. So this is a Raoult's law equation, second form of Raoult's law's equation. So what is x2? See, mole fraction of solute. What is mole fraction? Mole fraction is defined as the ratio of number of moles of one component to number of moles of all the components in the solution. Mole fraction of solute means number of moles of solute by total number of moles of all the components in the solution. So x2 is equals to n2 by n1 plus n2. I substitute here. Then P naught minus P by P naught equals to n2 by n1 plus n2. See here, Raoult's law is applicable to very dilute solutions. In very dilute solutions, when compared to number of moles of solvent, number of moles of solute is very less. So n2 is very less than n1. Just we are ignoring n2 value when compared to n1 in denominator. Then P naught minus P by P naught equals to n2 by n1. So n2 means what? Number of moles of solute, means weight by gram molecular weight of solute. N1 means what? Weight of solvent by molecular weight of solvent. We just substitute those terms in this equation. Then we get P naught minus P by P naught equals to weight by molecular weight. So here weight by gram molecular weight are taking. So just I convert this one directly, mW by capital W. Small w is what? Weight of solvent, weight of solute, molecular weight of solute, molecular weight of solvent, weight of solvent. P naught is vapor pressure of pure solvent, P vapor pressure of solution, vapor pressure of pure solvent. So this is one form of Raoult's law. From this we have to determine the relative lowering of vapor pressure of the solution having non-volatile solute and molecular weight of solute, and see the relation between them. RLVP is inversely proportional to the molecular weight of non-volatile solute. It means any colligative property is inversely proportional to the molecular weight of the solute. And see, we have a relation from molality and mole fraction. Mole fraction of solute is equals to molality of solution by molality plus 1000 by gram molecular weight of solvent. I substitute here. I substitute x2 relation at x2. Then I get P naught equals to molality by molality plus 1000 by gram molecular weight of solvent. If solvent is water, I write 18. 1000 by 18 means 55.5. So from molality we can get RLVP. Okay, this is about Raoult's law. And see, what are the limitations of Raoult's law? Raoult's law is applicable only to ideal solutions. Raoult's law is applicable to only ideal solutions. What are ideal solutions? Ideal solutions are the solutions which are obeying the Raoult's law. Raoult's law is applicable to dilute solutions. It is applicable to dilute solutions. Raoult's law is applicable when we are taking the non-volatile solute. Non-volatile solute. And fourth one is, whatever the solute we add it to the solvent for getting solution, that solute undergoes neither association nor dissociation. Then only Raoult's law is applicable. Okay, neither undergoes association nor dissociation. These are the limitations of Raoult's law. What are the limitations? Raoult's law is applicable to ideal solutions. Raoult's law is applicable to dilute solutions. Raoult's law is valid when non-volatile solute is added to the solution. Raoult's law is applicable only the solute undergo neither association or dissociation. So this is about Raoult's law, right? Well, now we will solve a problem now. Here the question which came in 2015 JEE mains. The vapor pressure of the acetone at 20 degrees Celsius is 185 torr. Acetone has taken in the beaker. So whose vapor pressure is how much? 185 torr. When 1.2 grams of a non-volatile solute is added. So its weight is how much? Small w? 1.2 grams. Non-volatile substance was dissolved in 100 grams of acetone. How much acetone has taken? Capital W. Weight of solvent is how much? 100 grams. Okay. Next, at 20 degrees Celsius means at a given temperature. There is no relation with vapor pressure. Its vapor pressure was 183 torr. The solution's vapor pressure it is P. P is how much? 183 torr. Here what comes? Difference in partial pressure comes 185 minus 183. How much? 2 torr. And acetone is the solvent. No. What is the molecular weight of acetone? Calculate how much the molecular weight of acetone. Molecular weight of acetone. See acetone formula CH3COSCH3. 3 carbons are there. No. 3 into 12. 36. And oxygen, one oxygen is there. Oxygen 16 atomic weight. 16. How many hydrogens? 6 hydrogens. 6 into 1. 6. 18. 58. 58 is the molecular weight of solvent. Okay, what we are going to calculate? Calculate the molar mass of the substance which is added. Molecular weight of substance is how much? It is capital MW. I am going to calculate small mw. So use the Raoult's law to calculate molecular weight of the substance which is added to the solvent. What is Raoult's law? P naught minus P by P naught equals to small w by small mw into capital MW by capital W. So this one we are going to calculate. Substitute all the values. Here 2 delta P by P naught, how much? 185 equals to small w 1.2 small mw into 58 molecular weight divided by 100 grams. So when you calculate this one, you get I think 64.38 grams. So the option is D. So this is the way to calculate molecular weight of the non-volatile solute which is added. Okay, practice this derivation and understand the concepts behind that. Then only you are going to solve the problems which are related to Raoult's law. Okay, thank you. Bye.